For the C problem here, we're told to solve for x, and so a technique I want to use when I have two radicals, like we do here, is I want to get one radical on one side of the equation and then the other on the other side. So that's what I've done here in the first step, is I'm going to take the square root of x minus 1, move it to the right side. So what I want to do is square both sides to get rid of the radical. So I do that, and I'm left with x plus 1 over 2, and then when I FOIL this expression right here, I'm going to get this, x minus 1 minus 2 square root of x minus 1 plus 1. And then so I multiply both sides by 2, I get this right here. And so now I kind of want to arrange things and combine like terms. So I'm going to bring the x over here with the 2x, bring the 1 over here as well, make the radical to the other side, make it positive. So I'm going to get 4 square root of x minus 1 equals x minus 1. Okay? So from here I can solve for x, or start solving for x, by combining the x's on the same side. So to do that, I need to divide both sides by square root of x minus 1. So that's what I'm going to do right here. So I'm going to divide both sides by square root of x minus 1. And now a thing to kind of keep in mind is with radicals, I can think of this as an exponent. So x minus 1, the square root is going to be raising that to the 1/2 power. So it's x minus 1, and then I guess divided by x minus 1 to the 1/2 power, or I can think of it as multiplying by x minus 1 to the negative 1/2 power. Either is the same, and either way, when I combine, or when I add the exponents, I'm going to be left with x minus 1 to the 1/2 power. So I have 4 equals x minus 1 to the 1/2 power, which is the same thing as a square root. Okay, if you're not sure how to work with fractional exponents, you may want to brush up on that. And then from here, though, what I can do is I can square both sides, and I get 16 equals x minus 1, so I get x equals 17. So 17 is my answer, and I guess technically we possibly could have two answers where both sides of this equation right here could be both 0. And for that to be true, x would have to be 1 for that to happen. But notice when I divide by square root of x minus 1, if x did indeed equal 1, what I'd have is something divided by 0, square root of x minus 1. If I plug a 1 in for x, I'd get square root of 0, so a 0 in the denominator. You cannot have that, so this would not even be an option, and your answer would just in this case be x equals 17.